Yeah. Hello, my dear students. So in this part, we are going to learn SN reactions. That means that nucleophilic substitution reaction. So before going to know that nucleophilic, actually the uh, SN reactions are the two types, as we know that SN1 and SN2. Okay, what is that? SN1 and SN2. So here SN reactions are, as I said, belongs to, it contains SN1 and SN2 reactions. So two types are there. So SN1 means that unimolecular nucleophilic substitution reaction, whereas SN2 means like a bimolecular, means that two molecules will be there, whereas in this type only one molecule is there. So that's why we can say as that unimolecular nucleophile means nucleophile is going to be substituted, while in this type two molecules are going to be participate. So that's why simply we can say as that bimolecular and nucleophile is going to be substituted. So that's why we can say as that bimolecular nucleophilic substitution reactions. So before going to know about this, that SN1 and SN2, how the nucleophile is going to be substituted. Okay, how it is going to be, what would be that leaving group and what will be the attacking group, we need to learn by the introduction part. Okay, so first we need to know like how these that leaving group and how the attacking group will be occurred. I will show you by writing that one example. Okay, so see beta, so in this reaction, what's we are going to be observing, whereas the CH3 CH2, this part is the same in the reactants side, and the CH3 CH2, this part is also same at the product side. So here this one we can say as that substrate or reactant. So what is going to be differ beta here? What is going to be differ? Just this one, the chlorine atom of the substrate and a hydroxy group of the product are the differ, isn't it now? So here chlorine is going to be replaced. That means that chloro atom is going to be replaced with that OH. That means that hydroxyl group. Okay. So that means here the chlorine atom, this one, we can say as what? Leaving group. What is that? Simply we can say as that leaving group or atom. Then this one OH group is going to be said to be as attacking group. What is that? Simply we can say as a attacking group, otherwise atom. Okay, so here what is that beta? The replacement of an atom, the replacement of what? An atom or group. Group of what? This is the substrate. This is what? Substrate. Otherwise simply we can say as what? We know reactant. So the replacement of an atom or a group of substrate by any another atom or group is known as what? Substitution reaction. This one, see beta, here I am showing you people. Okay, is known as what? Substitution reaction. So simply how can we say that a substitution reaction? The replacement of what? Okay, are you following now? The replacement of an atom or a group of substrate with any another atom or group is known as what? Substitution reaction. So here this process is done with the help of what? Here, so here one of that nucleophile should be that replaced. So here that OH group is always should be taken with the NaOH. Okay, so this reaction is that carried under what? In the presence of what? NaOH. So that means that here that chlorine group, this one, that chlorine group or that atom is replaced with what? OH group. So here OH minus. We know that that nucleophile is going to be substituted. So hence it is known as what? Nucleophilic substitution reaction. This is the basic part. This is what? A basic part. See, let us check one another example. Okay. Yeah. Okay, beta. So what is we are going to be observing compared to that first example and that second example? Here chlorine atom is going to be replaced with that OH group, and here OH group is going to be replaced by chlorine atom, isn't it? Now, so that means here OH group is said to be as what? Leaving group. Okay. Now the chlorine atom here said to be as that attacking group or atom, whatever it may be. Okay. So if the chlorine atom it wanna be replaced, if it wanna to be like replaced by that OH group, here what type of that reagent is going to be applying? NaOH. If that OH group it wanna be as a living group, if it wanna be like replaced by that attacking group of that chlorine atom, here what type of that reagent should be taken? That is the most and that most important one. We should get PCl5, phosphorus pentachloride. Clear na? Okay. Remaining part is the same. See, this one is the same. Only what is going to be replaced? Huh? What is going to be replaced here? The hydroxy group of the substrate is replaced by chlorine atom in the presence of what? PCl5. Clear beta? So these are the two examples. Chalo. Let us see one another example. Okay, the third example. See beta. So in the third example, yeah, what we are observing. Could you guess the name of the compound? Hmm? Just please think one. Just pause the video and the think it once. Okay, this one. This one is known as what? Vinyl. Vinyl group. CH2 double bond. CH is nothing but what? Vinyl. So vinyl key, if we attach that one more alkyl group, this one means along with this one also CH3, then we can say as that allyl group. The complete compound is known as what? Allyl. So from this that allyl, one of the hydrogen, just for that easy convert, just I written that separate instead of that CH3. Then this hydrogen is known as what? Allylic hydrogen. What is that beta? Allylic hydrogen. So here remaining this, the total compound is the same, isn't it now? Towards the compared to the substrate side and that product side, only this one is only differ. This one, the hydrogen. So in this place here bromine atom is that replaced. So that means that allylic hydrogen is that replaced by what? Bromine atom. So that means here allylic hydrogen is known as what? Living group. Whereas this that bromine atom or bromine group is said to be as that attacking group. So how it is possible? So what type of that reagent should be applied over here for the substitution of this that allylic hydrogen to attacking group of the bromine atom? So could you guess anyone? Yes, I will tell you beta. So here NBS, that means N bromosuccinamide over carbon tetrachloride over CCl4 can be used as a solvent. So what is the NBS? N bromosuccinamide, which it is converts the allylic hydrogen as a living group. On this living group of this that hydrogen atom is going to be substituted by that bromine atom. So N bromo, suppose if here chlorine is taken, then here we should get as that N chlorosuccinamide. If it is that iodine, then NIS should be taken. Okay now, so here we taken that bromine, so that's why here we take a bromo. Otherwise suppose if it is that chlorine is taken beta, Then how can we write? NClS means bromon, chloro, and suppose if it is that iodine is taken, then simply we can write as that NIS. Okay, simply we can write as what? N-iodosuccinamide. So what is the structure of that NBS? Let us know. Okay, see better. So how I'm going to draw the structure of this, that NBS. So here I'm going to take in that nitrogen, okay, which it is connected with that mm, 4 carbon ring, okay, like 1, 2, 3, 4, okay. So here this carbon double bond, that means that ketone group, sorry, yeah, C double bond O group, and here it is also C double bond O group. And here if we attach, so actually we know that the nitrogen valence is that 3, so here we can get that one another. If it is that bromine, then simply we can say as that N bromosuccinamide. If it is that iodine is taken, N iodosuccinamide. If it is that chlorine is there, N chlorosuccinamide. Okay na, get it na? So what is the name of the compound? NBS, N-bromosuccinamide. And its IUPAC name, could you guess better? What is the IUPAC name? Simply we can write as that 1 bromo, 1 bromo, and the 2 comma 5, 1 second carbon. So means suppose here that instead of that carbon here we taken that nitrogen, isn't it now? So 2, 3, 4, and 5. So that's why 1 bromo, 2 comma 5, okay, 2 comma 5 pyrrolidine. And how many number of that ketones are there? 2. So that's why simply we can say as that dione. So this is the IUPAC name of this compound. So this type of that reagent should be used over here in the presence of what? CCl4 for the conversion of what? That haloallylic hydrogen is going to be replaced by bromine. Clear? Okay. Now, finally, actually, yeah, tell me one thing better. So, what is the main use of this one, NBS? What is the main use? Why it is going to be used here? So, actually, this is that N-bromosuccinamide is mainly used in radical substitution. Okay, very important point. Please note, it's mainly used in what? Radical substitution. What type of substitution? Radical substitution. Like what type of electrophilic addition and electrophilic, like what? Electrophilic addition and electrophile substitution. Electrophile substitution. Okay, this one H plus allylic hydrogen is that electrophile is going to be substituted by that bromine, so that's why here that NBS is applied. Got it now? Chalo beta. And finally the last example, that fourth one. Yeah, ha beta. So in that fourth example where we know that this is one of that benzene ring, that means that aromatic ring, and each aromatic is contains that hydrogen atom. So simply here that a hydrogen of this the ring should replaced by NO2. Here I am taking the NO2 group. So that means here what type of the reagent is present? Could you guess? Could you beta? Okay, I will tell you. So whenever this that aromatic ring is heated, the presence of concentrate nitric acid HNO3, simply we can write yeah OH minus and NO2 plus, isn't it now? OH minus and NO2 plus. So this NO2 plus, that means that here what type of process is going to be occurred? Electrophile addition or electrophile substitution. This is that electrophilic substitution. This one NO2 plus, Hana, like this, isn't it? So that means this one is a leaving group and NO2 is attacking group. Okay, yeah. So these are the little bit introduction about what is the leaving group, what is the attacking group, and nucleophiles. See here, I got you the 4 examples, that basic level of the examples. Okay, if you want, just you can get the screenshot, otherwise that just pause the video and you can note it better. So first example, okay, and here that I didn't write that statement wise is the waste of the time. So by a good student is always can be imagine a statement by viewing, by seeing, by observing the reaction mechanism. Okay, so this is the example 1 and this is the example 2. Okay, and this is the example 3 and example 3 of that NBS. Here I given the structure. Okay, and finally this is the example 4. Okay, now let us know the types of substitution reactions. Okay, yes beta. So types of substitution reactions. So substitution reactions are going to be classified into 3 types. Substitution reactions are classified into 3 types: type 1, type 2 and type 3. So these are classified depending upon the nature. So how they are going to be classified depends on nature. Nature of what? Attacking group. Nature of depend. Sorry, not depend, it's based on. Is the types are classified based on the nature of attacking species, we can say, as otherwise that attacking group. So what are the 3 types? See, the first one is nucleophilic substitution reactions, means SN reactions. Second one, electrophilic substitution reaction, means SE. Whereas third one is free radical substitution reaction. So 3 types are there. So once again I am going to repeat what is that. The substitution reactions are classified into 3 types and these are classified based on what? The nature of attacking group, like in the previous page, like I'm already given what is the leaving group and that attacking group. Okay, so what are they? First one is what? Nucleophilic substitution reaction. Second one is electrophilic substitution. Okay, third one is what? Free radical substitution reaction. But here in this topic we need to learn only nucleophilic substitution reaction. Clear beta? Yes beta. Yes beta. So as I said, here in this topic we need to learn only what? Nucleophilic substitution reactions. Is again classified into the 2 types. What is that? First one is that aliphatic nucleophilic substitution. Aliphatic means what? Open chain. Aliphatic means what? Open chain nucleophilic substitution reactions. Whereas the second one is that aromatic nucleophilic substitution reaction. So here first we need to learn about this one. Okay, aliphatic nucleophilic substitution reactions. Okay, better. So let us know these aliphatic nucleophilic substitution reactions. The first one. Okay, so the first point, whereas these reactions is mainly given by those compounds which have the nucleophile, means that negatively charged ions. What is that? The nucleophilic groups. Nucleophilic group can behave as a nucleophilic group can behave as a living group, not electrophile. What is that? Nucleophile atom or the group should be as what? That living group which can easily displaces. Okay now, next, the second point here, the weaker the basicity, means the basicity of that group, if it is that weak, then which can easily living. No, not understood na. Chalo, but I will give the relation between that living power and basicity. Okay. See beta, so this is one of the relation between what should be, it is very important. So that's why just I am keeping in the box. So the living power of the group is always is inversely proportional to basicity of the group. Okay. So that means if the weaker the basicity, if the basicity is that very weak, then which it can easily leave the group. That means that's it, that's all. Okay now, so what is that? If the basicity of the group is that weak, the better is the living, the better is the living. So see here, I'm going to given that one order of the living power of the sum of the nucleophiles. Okay. Better. So here I'm going to write the order. What type of that order? Decreasing order. Decreasing order of what? The living power. The living power of what? Nucleophiles. Okay. Yeah, beta. So it's taken that little bit the time. So that's why just I pause the recording. So this is the decreasing order. What is that? This is the decreasing order of the living power. This is the decreasing order. Okay. This is what? The decreasing order of the living power. Like this, like this. Okay. So this is the decreasing order of the living power of the nucleophile. So which one is having that least living power capability? This one. Okay. Clear. And which one is that highest living power of the nucleophile? This one. Okay. Why? So how can we remind beta? How can we see what is the common here? I'm going to show you this one. See, so SO3, this one is the common. SO3 here, SO3, this is the common. Okay. SO3 is the common. This is the easy method to remember. Okay. So 1, 2, 3, 4, 5. So in this that 5 orders, SO3 is the common. Then the first one, trifluorocarbon, means that CF3, being as that fluorine is that high electronegativity. So high electronegativity, negative charge can be as what? Nucleophile. So highest electronegativity, its value is that 4, we know that. So that's why that CF3 is taken. Next one is that bromine. Okay, CF3 tarvata enti beta? Bromine. Which bromine? Bromobenzene, like this. So E compound, this one. Next bromobenzene tarvata toluene. Okay, bromine place lo next em gurtu pettukuntam ikkada. Okay, CH3 methyl. Next one just phenyl, this one. Okay, simply we can write as that C6H5 also instead of this one. What is that? Simply we can say as that phenyl. Okay, last one is that methyl. Okay, this one is also R and this one is also R, but that phenyl group is having highest living power than that of what? Alkyl group. Okay na, which it is connected with that SO3 minus SO3 minus SO3 minus. Okay na, so what is the order first? CF3 of SO3 minus, bromobenzene of SO3 minus, okay, toluene of the SO3 minus, next phenyl of SO3 minus, and methyl of SO3 minus. So this is the decreasing order. Once again, just please pause the video and that practice once in the same manner. Okay, first you need to draw that SO3 minus means S double bond O and that O minus. Okay, like 1 2 3 4 5 5 times. The first one is that CF3. Just please close your eyes and that please be remember better. What is that? First one is that CF3. Next one is that bromobenzene. Next one is that toluene means methyl benzene. Next one is that phenyl. Next one is that CS3 methyl. Okay, so దీని తర్వాత ఏం వస్తుంది మళ్ళీ నెక్స్ట్? ఓకే, iodide ion, iodine. Next bromine. ఓకే, దాని తర్వాత ఏంటి? CO2 minus కి what is should be that attached here? CF3. ఓకేనా? ఇక్కడ ఇగో ఇదే కాంపౌండ్, ద సేమ్ కాంపౌండ్ షుడ్ బి దట్ అటాచింగ్, బట్ హియర్ దట్ SO3 మైనస్ అండ్ CO2 మైనస్. ఓకేనా? మరి ఈ రెండింటికి కంపారిజన్ చేస్తే SO3 మైనస్ అండ్ CO2 మైనస్. సో SO3 మైనస్ ఈస్ హ్యావింగ్ దట్ స్ట్రాంగ్ లివింగ్ పవర్ ఆఫ్ ద న్యూక్లియోఫైల్. ఓకేనా? సో ఇక్కడనేమో మనం SO3 మైనస్ తీసుకున్నాం, ఇక్కడ CO2 మైనస్. రిమైనింగ్ ఇస్ ద సేమ్ CF3. ఓకేనా? Next H2O plus means protonium ion. This one is what? Protonium ion. Next chloride and fluoride ion. Last one is that methyl group of the CO2 minus. So this is the very important decreasing order. Decreasing order of what? The living power of the nucleophile. As we learn, the relation between the living power of the group is what? Inversely proportional. Is inversely proportional to what? Basicity of the group. So see, suppose if this living power is having that more, okay, that means the compound of that basicity will be low. అంతే కదా బేట. ఇప్పుడు ఈ కాంపౌండ్ కి ఇప్పుడు బేసిసిటీ ఆఫ్ ద గ్రూప్ లో ఉంది కాబట్టి దిస్ వన్ ఈస్ హ్యావింగ్ దట్ గ్రేటర్ ఇన్ దట్ లివింగ్ గ్రూప్. గ్రేటర్, సి ద గ్రేటర్ ఇన్ ద లివింగ్ గ్రూప్. అంటే ఇక్కడ క్వశ్చన్ మనం 2 టైప్స్ గా మనం వేరియేషన్ చేసుకోవచ్చు. ఓకేనా? సో lower in the basicity of the groups, that means that this one is having that, this one is having that lower in the basicity, which is greater in the living power. Clear? So just please pause the video and the order should be noted. Once again I am repeating that very important one, very important one. So that's why this order should be noted. Clear? Okay, chalo next. So not only this, we have that some other, okay, some other nucleophilic groups also there can behave as a living group. Yeah, beta. So as I said, some other nucleophilic groups. So not only this one. So few more that examples are there. Okay, some other nucleophilic groups are there which can behave as a living groups. They are, yeah. So here I'm writing trialkyl amine. So simply we can write as that NR3 plus. Okay. This one can also behave as a living group, NR3. Next nitrogen, N2. So N2 ni ela rastam eta manu? How can we write? Triple bond N, like this. Okay. Next one more, N3 minus means azide ion. N3 minus is also can be as what? A living group. Next alkoxide ion, that means that OR minus, like OCS3 minus. Got it now? Otherwise that O which it is attached to that benzene ring. Okay. And the OH minus also can be as what? All these nucleophilic groups so can be as what? As a living group. So in these reactions, what happens, so the leaving group of the substrate is going to be replaced by another nucleophile, isn't it now? So in that previous reactions of that 4 examples, where we learn what is that, one of the leaving group is going to be one of the leaving group of what, the substrate, it is going to be replaced by what, another nucleophile. So how it is going to be recognized? Okay, how it is going to be recognized? Here I would like to write one of the statement which it is that easy for you. Okay, yeah beta. So according to what I said, the leaving group of the substrate is replaced by another nucleophile. Okay, if the reagent, what is that, if the reagent, if it is that neutral అనుకుందాం, ఓకేనా? మరి అలాంటప్పుడు ఎట్లా? If it is that neutral means, so for example, if that NaOH is taken, okay, it is the neutral reagent. Okay, then ఎలా చెప్పొచ్చు, yeah, we can separate out as that Na plus and OH minus. This one is that nucleophile, this one now can be as what, electrophile, but basically it is that neutral. So if the reagent is that this one, like if it is that neutral, then leaving group is that replaced by, what is that, the leaving group is always replaced by that negative part of the reagent. Please understand, my dear students, this is the negative part of the reagent is only replaced by what? Okay, negative part of the reagent is replaced by leaving group. See how I will show you by one example. With example, sorry, RL means the reactant of any alkyl group or something, blah blah blah. Okay na? So L here, that stands for that leaving group. So here I taken one of the reagent. Here I taken the reagent like neutral. So that means in the neutral, one of the component can be as what, like positively charges electrophile and negatively charges nucleophile. Okay, so now tell me beta, according to this statement, okay, what's going to be happen over here? How can we write? Or this, the leaving group is going to be replaced by what? Always that negative part of the reagent. This is completely what? A reagent. What type of that reagent? Neutral reagent. Then the leaving power, sorry, that leaving group is going to be replaced by negative part of the reagent. Then how can we write? R NU1 rasna mana. Okay na? Okay, and remaining is that leaving group L, అప్పుడు ఏమవుతుంది అక్కడ, నెగిటివ్ పార్ట్ వస్తుంది, L minus. Okay na? Chalo, one more example, one more type. I think that you followed this one, you understood this one, you got this one. Okay, chalo. Yeah, okay guys, so that one more important point I'm going to write as a statement wise. Okay na? So let us pause the video after that to write that statement, which can just save our the time. Okay na? Yeah, so in SN reactions is always, okay, what should be done? Yeah, this one beta. Okay na? Is that very easy? So that's why just I written like in this manner. So in that nucleophilic substitution reactions, what happens is always the basicity of that leaving group is always should be less than that of the basicity of incoming group. So that means incoming means what? Attacking group. అంటే అటాకింగ్ గ్రూప్ బేసిసిటీ అనేది ఎక్కువ ఉండాలి బెట ఎప్పుడైనా సరే దేనికంటే లివింగ్ గ్రూప్ కంటే. ఆర్ యూ ఫాలోయింగ్ నా? సో ఈ లివింగ్ గ్రూప్ బేసిసిటీ ఎలా ఉండాలి? షుడ్ బి లో. అండ్ ఈ అటాకింగ్ గ్రూప్ ఉంది కదా రియేజెంట్ లో, ఇది ఏదైతే అటాక్ అవుతుందో ఇక్కడ దిస్ వన్. ఓకే, ఈ అటాకింగ్ గ్రూప్ ది బేసిసిటీ ఎలా ఉండాలి? షుడ్ బి హై. దెన్ ఓన్లీ దట్ న్యూక్లియోఫిలిక్ సబ్స్టిట్యూషన్ రియాక్షన్స్ ఈజ్ అకర్డ్. ఓకేనా? అండర్స్టూడ్ నా దిస్ వన్? సారీ, అంటే దీన్ని మనం ఇంకోలా కూడా చెప్పుకోవచ్చు బేటా. ఎలా? సి, ఎలా చెప్పుకోవచ్చు? ద స్ట్రాంగ్లీ బేసిక్ న్యూక్లియోఫైల్. దిస్ వన్ ఈజ్ వాట్? స్ట్రాంగ్లీ స్ట్రాంగ్ basic nucleophile. That means that attacking group. Okay na? So the strong basic nucleophilic group is going to be is replaces replaces దేన్ని రీప్లేస్ చేస్తుంది? This one. It is weakly basic nucleophilic group. It is what? Weakly basic న్యూక్లియోఫైల్. దాన్ని రీప్లేస్ చేస్తుంది. గ్రూప్ ఆఫ్ వాట్? ఈ వీక్లీ బేసిక్ న్యూక్లియోఫిలిక్ గ్రూప్ ఆఫ్ వాట్? దేంది ఇది? సబ్స్ట్రేట్. దేంది బెట ఇది? సబ్స్ట్రేట్. అంటే వెరీ సింపుల్, ఇదిగో దీంది బెట, దిస్ వన్. ఓకేనా? లో ఉండాలని చెప్పాను కదా. ఓకేనా? సో shall I give the one example based on this? This is a very good example. See, here I am giving R. First here I am taking that chlorine atom. Okay, yeah, క్లోరిన్ కంటే ఎక్కువ స్ట్రాంగ్ బేసిక్ న్యూక్లియోఫైల్ అంటే మనం ఇది ఎక్కడ నేర్చుకోవచ్చు? నెగిటివ్ ఇండక్టివ్ ఎఫెక్ట్ అని పార్ట్ ఉంటుంది బెట. నెగిటివ్ ఇండక్టివ్ ఎఫెక్ట్ -i ఆర్డర్ అని నేను రాయించాను, అక్కడ ఒకసారి చూసుకోండి ఒకసారి. యూ పీపుల్ నో అబౌట్ దట్ వన్. ఓకేనా? like according to that order wise, just I given a statement to you in that offline class. Okay, like how to remember that very easily, adokasari chuskondi. Otherwise that I will tell you later about that one. So chlorine, ikkade undali r, that chlorine should be comes out. Okay, మరి ఇక్కడ ఏ ఉండాలి? షుడ్ అంటే గ్రేటర్ దాన్ దట్ ఆఫ్ దిస్ వన్. దీనికంటే ఎక్కువ స్ట్రాంగ్ బేసిక్ నేచర్ అయి ఉండాలి. ఏంటది? OH మైనస్ ఆర్ ఇంకేదైనా ఉండొచ్చు. ఓకే, ROH. అలాంటప్పుడు దీన్ని ఏమని రాసుకోవచ్చు? NaOH. సో దిస్ దట్ Cl మైనస్ ion is going to be combines with what? Na plus. comes out as ఏ విధంగా? as a NaCl. క్లియర్? ఓకేనా? So very 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 important. Okay, so here ఏమవుతుంది బేటా? the basicity of OH minus, the basicity of what? the OH minus is more basicity. Okay, the basicity of OH minus is that more than that of what? దీనిది low basicity. Hence the OH minus is replaces chlorine. So that means here chlorine should be that leaving group and that OH minus should be tell me, attacking group. So that means based on this the statements is always that attacking groups should be ఎలా ఉండాలి? ఎలా? మోర్ బేసిసిటీ. ఇలా కూడా మనకు స్టేట్మెంట్స్ వైజ్ క్వశ్చన్ అడగొచ్చు బెట. సో ఆల్వేస్ దట్ అటాకింగ్ గ్రూప్స్ షుడ్ బి మోర్ బేసిసిటీ. ఓకేనా? అండ్ దట్ లివింగ్ గ్రూప్ షుడ్ బి ఇస్ ఆల్వేస్ లో బేసిసిటీ అయి ఉండాలి. ఓకేనా? ఇప్పుడు దీన్నే ఇప్పుడు నేను ఇలా ఉల్టా రాశాను అనుకోండి బెట. సి, అది రియాక్షన్ ప్రొసీడ్ అవుతుందా? సి, ROH తీసుకున్నాను. ఓకేనా? అండ్ హియర్ RCl. ఓకే, OH మైనస్ బయటికి వెళ్ళిపోతుంది. అంటే ఇక్కడ ఏమై ఉండాలి? గెస్. క్లోరిన్ ఈజ్ దట్ అటాకింగ్ గ్రూప్ అయింది ఇక్కడ. క్లోరిన్ ఏమైంది ఇక్కడ, అటాకింగ్ గ్రూప్ అయింది. అండ్ ఓహెచ్ మైనస్ ఏమైంది, లివింగ్ గ్రూప్. అంటే ఇక్కడ ఏం ఉండాలి, ఈ ఆక్సిజన్ ఓహెచ్ మైనస్ బయటకు వెళ్ళిందంటే క్లోరిన్ ఇక్కడ ఉండాలి అని అంటే ఇట్ షుడ్ బి దట్ హెచ్సిఎల్ అయి ఉండాలి అనుకుందాం. ఓకేనా, మరి ఈ ప్రాసెస్ కరెక్టేనా, టెల్ మీ. సో హియర్ ఏమవుతుంది ఇక్కడ, chlorine is that lower basicity than that of that OH minus, we know that. ఓకేనా, అకార్డింగ్ టు ఇది ఎక్కడ తెలుస్తుంది మనకి, ఎలక్ట్రోమెరిక్ ఎఫెక్ట్స్ లో ఇండక్టివ్ ఎఫెక్ట్ ద్వారా తెలుస్తుంది మనకు, అదొకసారి చూసుకోండి. ఓకేనా, జనరల్ ఆర్గానిక్ కెమిస్ట్రీ లో వస్తుంది ఆర్డర్. ఓకేనా, మరి ఇక్కడ ఇది ఈ లివింగ్ గ్రూప్ కి ఇక్కడ ఏముంది బెట, ఇస్ దట్ మోర్ బేసిసిటీ. మరి మోర్ బేసిసిటీ ని లో బేసిసిటీ రీప్లేస్ చేస్తుందా, లేదే, నో, never. So that's why this type of the reaction is that not occurred. Clear? Okay na? Chalo beta. Okay beta. So according to this topic, now I'm going to give the few, or we can discuss the one question. Okay. Based on this. Yeah. Now I'm going to write the one question. Okay guys, so let us check this question. So here that we need to arrange the living ability, okay, the living power or that living ability of the given the compounds, like that 4 compounds is given, and we should arrange in the decreasing order of what, nucleophilic substitution reaction. Okay, so take it once. This is the first one. ఎక్కడుంది ఇది మనం ఇచ్చిన ఆర్డర్లో, ఒక్కసారి పైకి వెళ్దామా మళ్ళీ. ఓకే, సి వేర్ ఇట్ ఈస్ దట్, CS3SO3 ఎక్కడున్నామా, హియర్ ఇట్ ఈస్ దట్ CS3SO3, అవునా, దిస్ వన్. సో దిస్ వన్ ఈజ్ గివెన్ యాజ్ దట్ ఫస్ట్ కాంపౌండ్. నెక్స్ట్ సెకండ్ వన్ ఏమి ఇచ్చాడు బేట, H2O ప్లస్, ఎక్కడున్నావు, దిస్ వన్ ఈజ్ గివెన్ యాజ్ దట్ second compound. Okay, third one iodide ion, now this one is given as the third compound. And fourth one, ఇది మరీ నేను ఇంత క్లియర్ గా చూపించాల్సిన అవసరం లేదు, జస్ట్ యూ కెన్ గెట్ ద ఆన్సర్ డైరెక్ట్లీ. CH3CO2 మైనస్, ఇది ఎక్కడున్నావు, CH3CO2 మైనస్, C ఇస్ ద లాస్ట్ వన్, ఇస్ ద ఫోర్త్ వన్. మరి ఇప్పుడు ఆర్డర్ ఏంటో అది కూడా ఏం అడిగాడు, what is asking the decreasing order of that SN reaction. చలో ఒక్కసారి నేను చూస్తాను మళ్ళీ, see and guess and write the answer. చలో, now I am going to write the answer. Okay, according to this one, see, so once again I am going to showing you clearly. If you want, just pause the video and try to write down by yourself. చలో, now I am going to write the answer. అండ్ చెక్ బెట, మీరు రాసిన దానికి నేను రాసిన దానికి ఆర్డర్. సో విచ్ వన్ ఈస్ హ్యావింగ్ దట్ గ్రేటర్, ఫస్ట్ వన్. ఓకే, దిస్ వన్, దీనికి ఎక్కువ ఉంది, ఏముంది, ద లివింగ్ పవర్. ఆఫ్టర్ దట్ థర్డ్ వన్, అవునా, థర్డ్ వన్ తర్వాత నెక్స్ట్ సెకండ్ వన్, అండ్ ద లీస్ట్ ఇంకేం మిగిలింది బెట, ఇక ఫోర్త్ వన్ ఈస్ ద లీస్ట్ వన్, CS3CO2 మైనస్. So this is the answer. Okay na, chalo, here I am going to write that one more question. Okay, chalo beta. So second one, which of the following has that maximum nucleophilicity? Out of this the 4 options, which one is having that maximum nucleophilicity? Chalo get cheyandi chuddam. Maximum అంటే మోర్ న్యూక్లియోఫిలిసిటీ, దేనికి ఎక్కువ న్యూక్లియోఫిలిసిటీ ఉంటుంది, కమాన్ గెస్, గెస్ చేయండి. I will show you. This one example, see, CS3 minus least Br minus O CS3O minus అంటే దీన్ని మనం ఎలా రాసుకోవచ్చు మనం just like that OR minus like చెప్పాను నేను ఇంతకు ముందే ఓకేనా and this one C this one like we can get it as that R అంటే like the CR3O minus చలో this one Br minus and that CS3 minus అంటే దేనికి maximum nucleophilus అంటే దేనికైతే లివింగ్ పవర్ తక్కువ ఉంటుందో that one is having that maximum nucleophilicity చలో దేనికి తక్కువ ఉంటుంది చెప్పండి which one beta obviously this one ఇగో ఇక్కడ దీనికి తక్కువ ఉంది కదా CS3 అంటే ఈ గ్రూప్ అయ్యో కనిపించట్లేదా యా this one CS3 minus so that answer should be that first option CS3 minus is having that maximum nucleophilicity. Why so? Living power తక్కువ ఉంటుంది కాబట్టి this one. Only why this one. So what is the answer beta for this one? Is the first option. Okay. Yeah, okay guys, so before going to end this part, so once again just please once again, this is the very that basic part of that nucleophilic substitution reaction and that a small introduction part. Okay, so please try to write on that notes. Okay na? And just if you want, just you can pause the video and go back and that once again just listen the class, but while explaining the main topic, just I will try to give that few questions, okay, in between the topic, means regarding about the topic only. Okay, in the next part we are going to learn asli maja aayega bolte na, like yeah, like that. Okay na? So in the next part we are going to learn asli topic, that means about SN1 and SN2, whereas in SN1 and SN2 like a unimolecular and that bimolecular, okay, which it is like a sp3 hybridizer and the sp2 hybridizer is there. So but basically which one is that highly preferenced? sp3 hybridizer of SN2 reaction as well as that SN1 reaction. sp3 hybridizer means what? Singly bonded. Okay na? After that we need to learn the differences between this SN1 and SN2 and we can discuss the few questions in that next topic. Okay na? So till then, bye bye, see you. Get ready for the next part.